you can take part in the conversation, okay? And having said that about logistics, let's get started. Mike, Ryan, all yours.
Okay, thank you, Pep. Yeah, so I'm Mike Henriksen. I work at Red Hat, and I'm going to be talking about data protection.
I'm Ryan Halsey. I work at NVIDIA. Sorry, I work at NVIDIA talking about forensics. Go ahead, Mike.
Yeah. So yeah, I'm gonna talk a little bit about data protection, what's available in KubeVirt now, what we're planning for the future, what some of the challenges there are, and but yeah, like Pep said, we're really interested in hearing from the community. This is Kubernetes data protection is a rapidly growing field or topic of interest. And we want to know what you're doing for data protection now, what primitives KubeVirt can provide. And to kick that off, we've got Ryan here to talk about his use case and how we can extend some of the, we are planning to extend some of the, data protection primitives to help him do forensics. And of course, there are a bunch of other things you can do with these primitives. So yeah, let's talk about it. Let's talk about what you're doing now, and maybe you can help us with some of the challenges. So, okay, what is data protection? So data protection is, the purpose of data protection is to ensure an application and its associated data can be restored quickly after any corruption or loss. So basically, backup and restore. And so what's available now? There's offline virtual machine snapshots. And I've done a terrible job of promoting this feature, so I will be going through the API and telling you how to use it. We'll talk about online snapshots, which will be coming soon, and they're crash consistent and application consistent time and God willing availability. And Velero integration. Velero is the #1 kind of Kubernetes backup solution or data protection solution right now. So we'll talk a bit about how KubeVirt is going to integrate there. Okay, so if you want to use KubeVirt snapshots, there are a couple things you got to do. First, in the KubeVirt realm, you have to enable the snapshot feature gate. KubeVirt's are the snapshots alpha feature in KubeVirt. So turn on this feature gate. There is should be documentation somewhere in the KubeVirt repo telling you how to do it. Right now, you can only snapshot your virtual machines. So VMIs and VMI replica sets to come. And yeah, offline snapshots, so your virtual machine has to be halted. For storage requirements, so if the big thing is, and the kind of one of the main drivers in this feature was we want to be Kubernetes native everywhere. So we are leveraging the Kubernetes volume snapshot API. Obviously, if we run QEMU VMs, and there are all sorts of capabilities baked into that. If you're using QCOW2 files, you can do snapshots, whatnot. We're not doing any of that. We are relying on Kubernetes. So you need a volume snapshot beta API deployed in your cluster, the CRD. There is a volume snapshot common controller that must be deployed as well, and webhook. So these are things that are available, and SIG storage maintains them. You can get them in GitHub somewhere. So because we're using the volume snapshot API for persistence, your volumes and your VMs that have to be data volumes or persistent volume claims, meaning if you're only using container disks, they won't be supported. We'll still back up your VM configuration in the snapshot, but we're not snapshotting any of your data. And of course, you need a CSI provisioner for your storage class that supports snapshots. Okay. So those are the table stakes there. Next, so if you want to snapshot a VM, again, make sure it's stopped and just submit a YAML that looks like this. Pretty easy. You can see the source is a virtual machine and it has a name. Okay, so, all right, so snapshot monitoring. So you can see buried in this YAML somewhere, there are a couple conditions, progressing and ready. So basically, you can use kubectl wait, I think it's called, and you can wait for the condition to be ready for when your snapshot is complete. So one interesting thing I want to point out at the bottom is this volume snapshot content name. So back here, we introduced this virtual machine snapshot resource, but there's also this VM snapshot content reference. Well, what is that? So there's a virtual machine snapshot content resource, and it is similar to, I don't know if you are familiar with the CSI volume snapshot API, there's volume snapshot and volume snapshot content. So a virtual machine snapshot is like the intention, the job I want to snapshot this VM. And the virtual machine snapshot content is the container that has the data and references to any data that are applicable to that snapshot. So you can see in here, we're embedding the virtual machine spec, embedding any persistent volume claim specs, and the names of any virtual machine volume snapshots that have been created. So when you submit a virtual machine snapshot, a virtual machine snapshot content will get created, and then the controller will create the volume snapshots and basically glue everything together in this snapshot content so that this is like the map of everything that is involved in a virtual machine snapshot. Okay, so snapshots are cool, but they're kind of useless without a mechanism to restore. So this is how you would restore a VM. There is a virtual machine restore resource, and you specify the target, which is a VM, and the name of the snapshot. Pretty straightforward. You can monitor this similar to how you monitor snapshot. So what goes on in the background here is that the restore controller will look at that virtual machine snapshot content resource, create PVCs from all the volume snapshots that are referenced there, wait for those all to complete, and then update the VM spec with the spec that is in the snapshot resource. So while all that is happening, progressing condition will be false, ready will be false, and then eventually it'll be true once everything has been created and glued all together in the new virtual machine spec. Cool. So offline snapshots, that's what we've got now. And we're working on online snapshots, but I just want to go into a bit of the challenges and what we need to address to make that possible. And this is an area where, you know, Kubernetes storage experts out there definitely chime in if you have any tips, tricks, or any quirks or features that may be applicable. So one thing to consider is that Kubernetes/CSI gives no consistency guarantees. So you can create a volume snapshot at any time, and there's no guarantee that, you know, the snapshot will be created, but there's no guarantee that, you know, the snapshot is going to be useful at some time in the future. You may have just snapshotted at a time when your file system is in a state where it couldn't be restored. So that's why, you know, offline snapshots, we know that nothing is being used. We wait until any pods that are referencing a PVC are gone, and then we snapshot when we know that they're not in use. So we really need to solve this consistency problem when we get to online snapshots. Another thing in this realm is when you have a VM that is usual, if your application is spread over multiple disks, you need a way to make sure that, all the disks are consistent amongst themselves. And there's work in the community to address that. There is a notion of a CSI volume group, which will be coming along very soon. I encourage you all to check out the data protection work group. They're doing some cool stuff. So that's one of the challenges there. How do we get snapshots that are usable? So for crash consistency, we really need to do an FS freeze at the file system level to make sure that the file system can be restored. So what FS freeze basically will flush any outstanding activity on a file system and block any future writes. I think things will just block until snapshot is created, and then of course you unfreeze, which will continue anything that was queued up or whatever. So for crash consistency, minimum you have to do an FS freeze, unfreeze. And again, the data protection workgroup knows about this, and there are a couple different initiatives. There's a container notifier, and there's also the execution hook, which has been around for a while. But the thing is, to do FS freeze, unfreeze, you need privileges typically. So if we can't get the kubelets to us, to help us out, we're kind of lucky in that we have Virt handler around, which is somewhat privileged. So the next step after crash consistency is application consistency. And for that, we need a way to QS on QS applications. And because we're virtual machines, there's a kind of extra level of work we have to do there. So we really need to integrate with the QEMU guest agent to have code running in the VM, do the proper, flush tables or whatever to get to the application and the state. So those are kind of a lot of the challenges there. It's just largely around synchronization, which I'm sure you all kind of expected. Cool. Right. And the other initiative that we're going to be working on in parallel is Velero integration. So Velero is, the #1 tool for data protection, backup in Kubernetes right now. So it provides data protection, migration, and disaster recovery are kind of the 3 use cases. So for data protection, it's popular. A lot of people, that's why we want to integrate with it. It has support for CSI snapshots. It has a lot of support for cloud provider stuff, which I think is less important for us, but interested to hear if you guys are running in the cloud and what you guys are doing for backups there. Migration and disaster recovery are kind of very similar use cases, but Velero has APIs to back up to object storage and RESTIC integration. So I don't know if you guys have used RESTIC before, but it's pretty cool. And so you could kind of, even on a bare metal cluster, bring up a Minio S3 server and using the RESTIC integration back up your disks in a relatively efficient way. So by default, Velero is pretty good at backing up, your entire namespace or your entire cluster, but it's not so great if we just want to back up, say, one VM. And that's why we want to create a KubeVirt backup restore plugin for Velero that will allow basically to traverse the KubeVirt object graph. So, Velero doesn't know when it sees a virtual machine spec that it has to also back up any PVCs that are associated to it or any other resources. So that's planned integration there. So definitely, love to hear what you guys are doing for backups now. How does this sound to you guys? Have you used Velero? Do you think this will work? We think it'll work, but so any feedback would be great. And yeah, so these are kind of the primitives that we're planning to provide now. And I'll hand it over to Ryan to talk about his use case and how we're going to extend KubeVirt to work for him.
Okay, so let's forensics. So forensics being like a use case of Snapshot. So to expand even on what when Mike talked about with live virtual machine snapshot and restore, that's kind of what in a lot of ways about. Be an example. Let's say that I like old video games, and I have one of my favorite video games of all time depicted here. And for old games nowadays, like a lot of times, those servers don't exist anymore. So let's say I decide that I want to host a cluster on my home network with this video game, so I can play with my friends. Let's say this runs Kubernetes, it runs KubeVirt. I have virtual machines, I have GPUs, I have a bunch of allow people to connect as guests to run in those virtual machines the game, and so that we can all play together. So they'll be playing, and they'll have a GPU attached to their virtual machine, and they'll be playing that game. So in this scenario, you can imagine where if I had someone to our cluster wanted to, let's say perhaps that maybe they weren't really standing there and they weren't really doing anything, and problem, that's cool. But what happens if I get a notification on my phone with monitoring saying that it's been breached? Well, that's not really a good thing. I can imagine that, oh, wow, something's weird happening. There's a person playing the game, but it's a little bit unusual. They're not really doing anything, and someone's breaching my network. So what am I left to do? So, in the scenario, I really want to look into what's happening with this virtual machine. I want to look into ways that I can examine it further, so see what's going on, and so that I don't encounter this in the future. So what would I look to do? So in this kind of use case, I have KubeVirt here, and I have my virtual machine, and I have workload. I want to make sure that my virtual machine can't cause any damage to any of the healthy workloads in my cluster. So I've decided I'm going to look at suspending it so I can do any sort of analysis later. Next slide. Okay, so I mentioned suspend. There we go. So I mentioned suspend. So what do I mean by that? Like, I have virtual machines running in my cluster, they're running games. I said suspend. Okay, well, two types of suspend that I'm referring to. So pause and save. Slightly different. Pause being that the hypervisor is going to suspend the virtual machine, and it's going to store its state in RAM until it's resumed. Save being that the domain state is going to be suspended, and it's going to be stored in persistent storage. So one being ephemeral, one being a little bit more persistent. And right now, pause is something that's already supported in KubeVirt. It's a condition that exists on a running virtual machine, and there's an API that you can call to actually pause a running virtual machine. So what does that mean? Next slide, please. So I'm going to pause this virtual machine. Here's what I get. I'm going to get a pause virtual machine is going to keep the virtual machine running with all its devices and resources in place. So like I mentioned, we have a virtual machine. It's got GPUs. That's got a GPU attached to it. One of my guests is playing a game in that VM. I pause it. Everything's going to stay in place. All the resources for it will remain in place. So with that high level, suspend is going to, in this case, suspending is going to be, I'm going to be able to suspend the misbehaving virtual machine, and I'll be able to resume it later for analysis. So it's perfect that, that solves my problem. I can keep playing the virtual machine, playing my game with my friends, and not have to worry about any sort of problems. And I can deal with it at a later date. So now I've got, what else? Suspend, I can suspend pass-through and mediated devices. So the physical GPUs or the mediated ones, I don't have to worry about that. So, but what does this not quite get me? Well, I can't resume multiple virtual machines. What I mean by that is, like, if I was a team administering this cluster, one of my coworkers say they wanted to also look at this virtual machine and forensically analyze it. They can't do it if I'm looking at it. They can't have their own copy without doing additional work. They could clone it if they wanted to, but they would have to do additional work. And the same for resume into a different namespace. You could have to migrate the virtual machine to a different namespace, let's say, so you can lock namespace, lock down the network to do some analysis. And then finally, virtual machine spend it for longer than a week. Like I mentioned, we're holding out to resources. GPUs are pretty valuable in my cluster. I probably don't want, if I have an increased load over the weekend, I don't really want to hold on to my paused virtual machine. So it works for, maybe a temporary amount of time and solves some of my problems, but maybe not something that I'd want to do long term. Next slide, please. Okay, so I'm going to talk at a very high level and sort of the future work. Mike mentioned doing live snapshots. So specifically, what I'm interested in when I describe the case is actually doing an online snapshot with Save. So what would this look like at a high level? Well, when you create a snapshot of a virtual machine, the Virt launcher, pause the virtual machine. We'll do a hot unplug of non-USB devices, and that's important because to an offline migration, this is essentially like a virtual machine migration. So it runs the same code path. So the non-USB devices will need to be unplugged, and then we actually execute a save to a location on the PVC. And the result is that we save RAM and VRAM disk, and will all end up in the PVC. The next slide, please. And so the same thing will happen for Restore, but now we're going to, or the inverse will happen for Restore. Now we're going to restore this, but we're going to clone the PVC when we go to Restore. We're going to look at recreating the VM with the clone PVC, reattach the devices, and actually do the restoration on the VM, and we locate the RAM and do that restore. And like I mentioned, one of the things we can do with this is now we can actually pick the namespace because it's a namespace operation, restrict everything to a namespace and do and restrict the network in the namespace and do our analysis in a safer place. Next slide, please. Okay, so what does this get us now? We're going to talk about save. So we can, when we save, we power off the virtual machine, we free up resource in the cluster. So high level, we're able to suspend, we're able to restore. We can only suspend mediated devices and when we're talking about save and not pass through. I mentioned VRAM and mediated devices earlier. That's the one exception to this. And then what else will we get out of this? Well, we can resume multiple virtual machines. We'll get this as part of this operation. Because of the cloning, we can resume it to a different namespace because this is equivalent to offline virtual machine migration. And then it makes it a little bit more appealing to keep our virtual machines suspended for longer than a week because my valuable resource, those devices, those GPUs, aren't going to be consumed. Next slide, please. So to kind of loop back and conclude the story on my cluster, the person that's misbehaving, I've paused their virtual machine or I've saved it and they're no longer able to play. And this is what they're left with. They can no longer play games with us in the cluster. Okay, so that concludes my example, and we can start with any questions.
So if you have a question or ideas about data protection, please just say, I want to speak in the chat, and I will enable presenter mode for you so that you can speak out loud. Or you can ask your question via text in the chat or in Slack, and I will repeat it. Okay, what do we got here? Okay, this is one from Alexander. Are you going to store the memory, etc., in the disk PVC, this interface? In the disk PVC, or would you need extra PVCs?
So in the case of so like with save, you would be able to, we actually talked about this in some of the community meetings. The first approach we were looking at doing is using the already attached PVC. So that RAM would end up in the same PVC with the assumption that the user attached it, that they'll have enough space to store RAM in there. There are other options where we could look at possibly adding new PVCs. There's a whole design document we kind of went through and discussed. Those are some other options, but the first one would be using the attached storage already.
Yeah, I think one idea that's floating around is to add, a volume type to virtual machines, VMS, that is like a memory volume type that can be used as a sort of scratch space, if you will, that when, if you want to do a snapshot or save that requires memory, we can dump it there and then take a virtual volume snapshot of that to restore it later.
Okay. Are vGPUs considered mediated or pass-through devices for suspend and resume?
I'm talking about them as mediated devices.
Okay. Dan wants to know, what do you consider the greatest challenges in front of you folks for implementation?
Definitely the synchronization. These are all things that are kind of, I think one of the challenges is going to be, going with the community and forging our own way. Like, I think the community is always going to be a little behind of what we want to do. So, some of these synchronization problems that they're tackling, can we wait for the proper API and implementation to be deployed, or do we have to come up with something ourselves? I think that's going to be an interesting balance, and just the fundamental challenges there of synchronization. I think, what I mentioned before, especially the issue around if your application uses multiple disks and they have to be synchronized, there's nothing you can do for that right now until we have volume groups where CSI is supporting, helps us out there.
Okay. Jose wants to know, is anybody collecting use cases for data protection in KubeVirt? And if so, where?
It's a good question. That's one of the things I want. So, as I mentioned earlier, I think I did a terrible job of promoting the Snapshot feature, and I hope people start using it more and there's more awareness out there. I don't, I'm not aware of any, use cases that I can share right now.
Okay. Rod wants to know, should the snapshotting feature be storage provider agnostic? They're running RKE plus Longhorn and have had some issues with snapshotting.
So, yeah, so that would mean not using CSI snapshots, I assume. And I think that's where, when I briefly talked about the Valero and Restic integration may come in, Restic to do incremental backups of your PVCs as they change. I don't see us. I think we'll our plan is to stick with CSI snapshots for now, but I think with Restic integration and Valero, you could have a solution that doesn't use CSI snapshots.